When calculating the service size for a multi-unit commercial building, it's important to use the correct demand factors to ensure an accurate and safe electrical system. We'll cover the demand factors for general lighting, receptacles, air conditioning and refrigeration, motors, specific equipment, and the house panel. For general lighting in commercial multi-unit buildings, while example D4 for multifamily dwelling can provide some guidance, the lighting demand factor allowance for commercial buildings differs. It is recommended to use Table 31.10 from IEEE 241/2021, titled Recommended Practice for Electrical Systems in Commercial and Industrial Buildings. For receptacles in commercial multi-unit buildings, again, it is recommended to use Table 31.10 from IEEE 241/2021. For other loads like air conditioning and refrigeration, you can refer to Table 31.10 of the manufacturer's data for the specific equipment. For motors, you can refer to Table 31.10 or Article 430 of the National Electrical Code (NEC). For specific equipment, it is recommended to consult the manufacturer's data or use estimates based on previous installations or similar applications. For the house panel, it is recommended to use demand factors for a single-family dwelling. Refer to Annex D, Example D1 of IEEE 241/2021. Now let's go through some example calculations. Firstly, general lighting for a commercial unit. Let's say each unit has 1000 watts of lighting load. Using Table 31.10, the demand factor for a retail store is 0.60. Therefore, the service lighting load for one unit is 1000 watts times 0.60, which equals 600 watts. Secondly, receptacles for a commercial unit. Let's say each unit has 800 watts of receptacle load. Using Table 31.10, the demand factor for a retail store is 0.50. Therefore, the service receptacle load for one unit is 800 watts times 0.50, which equals 400 watts. Thirdly, air conditioning for a commercial unit. Let's say each unit has a 3000 watt air conditioner. Using Table 31.10, the demand factor for air conditioning in a retail store is 0.70. Therefore, the service air conditioning load for one unit is 3000 watts times 0.70, which equals 2100 watts. To calculate the total service size, sum the calculated loads for all 22 units plus the house panel loads to determine the total service size required. Remember that these are just examples, and the actual demand factors and load calculations will vary depending on the specific characteristics of the commercial building and its units. Always consult the relevant codes, standards, and manufacturer's data for accurate and safe electrical system design. Now let's delve deeper into understanding how to effectively utilize IEEE 241/2021 and the NEC for determining demand factors in commercial multi-unit buildings. The IEEE 241/2021 provides a comprehensive guide to electrical systems in commercial and industrial buildings, offering recommended practices for various aspects of electrical design, including demand factors. Table 31.10 within this standard is particularly useful for determining demand factors for different types of loads in commercial buildings, such as retail stores. This table provides demand factors for general lighting, receptacles, air conditioning, and other types of loads, based on the specific occupancy and characteristics of the building. Understanding how to properly interpret and apply these demand factors is crucial for accurately calculating the service size requirements for a commercial multi-unit building. When using Table 31.10, it's important to carefully consider the specific occupancy and characteristics of each unit within the commercial building. For example, a retail store will have different demand factors than an office space or a restaurant. Therefore, it's necessary to identify the primary function of each unit and select the appropriate demand factors from the table accordingly. In addition to Table 31.10, the NEC also provides valuable guidance on demand factors for various types of loads in commercial buildings. Article 220 of the NEC covers branch circuit, feeder, and service calculations, including demand factors for lighting, receptacles, and other loads. While the NEC provides general guidelines for demand factors, it's important to note that these guidelines may not always be applicable to specific commercial building scenarios. In such cases, it's necessary to consult other resources, such as IEEE 241-2021 or manufacturer's data, to determine the appropriate demand factors. For example, when calculating the demand factor for air conditioning loads in a commercial building, the NEC provides general guidelines based on the total connected load. However, these guidelines may not accurately reflect the actual demand of the air conditioning system, especially in buildings with energy-efficient HVAC systems or variable refrigerant flow (VRF) systems. In such cases, it's necessary to consult manufacturer's data or use engineering calculations to determine a more accurate demand factor. When calculating the service size for a multi-unit commercial building, it's essential to consider the diversity of loads and the probability of simultaneous operation. The demand factor accounts for the fact that not all loads will be operating at their maximum capacity at the same time. By applying the appropriate demand factors, you can reduce the calculated service size and avoid oversizing the electrical system, which can lead to increased costs and reduced efficiency. In addition to demand factors, it's also important to consider other factors that can affect the service size requirements for a commercial multi-unit building, such as future expansion, energy efficiency, and code requirements. For example, if the building is expected to undergo future expansion or renovation, it's necessary to account for the additional electrical load that will be added to the system. Similarly, if the building is designed to be energy efficient, with features such as LED lighting, high-efficiency HVAC systems, and smart controls, it may be possible to further reduce the service size requirements. It's also important to ensure that the electrical system complies with all applicable codes and regulations, including the NEC local building codes and utility requirements. These codes and regulations may impose specific requirements on the service size, demand factors, and other aspects of the electrical system design. To illustrate the importance of using the correct demand factors, let's consider an example of a commercial multi-unit building with 22 retail units plus a house panel with lighting and motor loads. Each retail unit has 1000 watts of general lighting, 800 watts of receptacles, and a 3000 watt air conditioner. The house panel has a lighting load of 2000 watts and a motor load of 5000 watts. Using Table 31.10 from IEEE 241-2021, the demand factors for a retail store are 0.60 for general lighting, 0.50 for receptacles, and 0.70 for air conditioning. For the house panel, we'll use demand factors for a single-family dwelling, as specified in Annex D, Example D1 of IEEE 241-2021. The demand factor for lighting in a single-family dwelling is 0.35 for the first 3000 watts and 0.25 for the remaining watts. The demand factor for motors in a single-family dwelling is 0.80. Firstly, let's calculate the lighting load for each retail unit. 1000 watts times 0.60 equals 600 watts. Secondly, let's calculate the receptacle load for each retail unit. 800 watts times 0.50 equals 400 watts. Thirdly, let's calculate the air conditioning load for each retail unit. 3000 watts times 0.70 equals 2100 watts. Now, let's calculate the total load for each retail unit. 600 watts plus 400 watts plus 2100 watts equals 3100 watts. Next, let's calculate the total load for all 22 retail units. 3100 watts times 22 equals 68,200 watts. Now let's calculate the lighting load for the house panel. The first 3000 watts has a demand factor of 0.35, so 3000 watts times 0.35 equals 1050 watts. The remaining 0 watts has a demand factor of 0.25, so 0 watts times 0.25 equals 0 watts. Therefore, the total lighting load for the house panel is 1050 watts plus 0 watts equals 1050 watts. Then, let's calculate the motor load for the house panel. 5000 watts times 0.80 equals 4000 watts. The total load for the house panel is 1050 watts plus 4000 watts equals 5050 watts. Finally, let's calculate the total service size required by summing the total load for all 22 retail units and the total load for the house panel 68,200 watts plus 5050 watts equals 73,250 watts. Therefore, the total service size required for the commercial multi-unit building is 73,250 watts or 73.25 kilowatts. It's important to note that this is just an example, and the actual service size requirements will vary depending on the specific characteristics of the building and its units. Always consult the relevant codes, standards, and manufacturer's data for accurate and safe electrical system design. The process of calculating demand factors and service size for commercial buildings can be complex, requiring careful consideration of various factors and adherence to relevant codes and standards. By following the guidelines outlined in IEEE 241-2021, the NEC, and other applicable resources, you can ensure that the electrical system is properly designed to meet the needs of the building and its occupants. Moreover, the NEC outlines specific requirements for overcurrent protection, grounding, and wiring methods. These requirements are in place to ensure the safety of the electrical system and to protect against hazards such as electrical shock, fire, and equipment damage. Therefore, it's crucial to follow these requirements carefully when designing and installing the electrical system for a commercial multi-unit building. In addition to the technical aspects of service size calculation, it's also important to consider the economic implications of electrical system design. Oversizing the electrical system can lead to increased costs for equipment, installation, and operation, while undersizing the system can result in inadequate power supply and potential safety hazards. Therefore, it's necessary to strike a balance between performance, safety, and cost-effectiveness when designing the electrical system for a commercial multi-unit building. Consulting with a qualified electrical engineer is highly recommended to ensure that the electrical system is properly designed and installed. An electrical engineer can provide expert guidance on demand factors, service size calculation, and other aspects of electrical system design, taking into account the specific requirements of the building and its occupants. In conclusion, determining the service size for a multi-unit commercial building requires a thorough understanding of demand factors, load calculations, and relevant codes and standards. By following the guidelines outlined in IEEE 241-2021, NEC, and other applicable resources, and by consulting with a qualified electrical engineer, you can ensure that the electrical system is properly designed to meet the needs of the building and its occupants while also ensuring safety and cost-effectiveness. Remember to always prioritize safety and compliance with applicable codes and regulations when working with electrical systems. Incorrectly sized or installed electrical systems can pose serious hazards to building occupants and can result in property damage or even loss of life. Therefore, it's essential to take the time to properly design and install the electrical system, following all applicable codes and standards and consulting with qualified professionals when necessary. By doing so, you can ensure that the electrical system is safe, reliable, and efficient, providing a comfortable and productive environment for the building's occupants. Lastly, it's important to stay up to date on the latest developments in electrical technology and codes. The electrical industry is constantly evolving, with new technologies and standards being introduced on a regular basis. By staying informed about these developments, you can ensure that your electrical system is always up to date and compliant with the latest requirements.